All right, so we're looking at random variables today. Now that we can find the mean and standard deviation of a random variable, the expected value and the standard deviation, we would also like to know the mean and standard deviation of a function of that random variable. So suppose the length of a taxi ride in miles, x is the length of a taxi ride in miles. Suppose that the mean of x is 5.2 miles and the standard deviation of x is 2.8 miles. You have two different taxi cab companies and they have different fare schedules. Fare is how much you're going to pay after riding in a taxi for a certain length of time. Company 1 charges $2.50 per mile and Company 2 charges $2 per mile plus an initial fee of $5. Thus, if we are interested in the total fare of a taxi ride Y, the two functions are the cost, the fare, okay, this is the fare, Y is the fare, how much it costs. For Company 1 is $2.50 times X. X represents the average length. Does it make sense that if you're going to figure out how much your taxi ride costs, you take how far you drove times the cost per mile? Okay, so it's just a very simple math function. The second company is going to charge $5 plus $2 per mile. So just for getting in the car, in the taxi, they're going to charge you $5. They want to make sure they make at least $5 plus $2 for every mile. Okay, so these are our functions. It says, how can we find the mean, the expected value or the mean, and the standard deviation for each case? Okay, here's how we do it. Back in chapter 6, we did some notes when we did chapter 6 the first time, and it was notes they had dot plots and test scores, and we did a dot plot of the test scores, and then I said, okay, I'm going to add 5 points to these, and then we made a new dot plot and found the mean and standard deviation. And what we found was that when you add a constant to every value in a data set, it changes the measures of position. The measures of position are mean, median, min, max, Q1, Q3, etc. The only one we care about here is mean. That's all we're finding, the mean. So when you add something to every data value in a set, you change the mean, but not measures of spread. So standard deviation is not affected by adding. So if we look up here at these two different cab companies, this plus 5 does not affect the standard deviation of the cost for Company 2, the fare, because adding a number does not affect the standard deviation. So if I were looking for the standard deviation of the fare for that cab company, adding 5 would not affect the standard deviation, only times 2. Okay, but when you multiply a value in a data set by a constant, it changes both the measures of position and spread. So multiplying by 2 and 2.5 is going to change both the mean and standard deviation of the number of miles or the cost. So we've got some formulas that we want to look at here, and these are from your book. These are actually from page 382. These are the formulas that we're using today in all of our problems. Okay, these are the formulas we're using. The standard sigma is the standard deviation of x, and that is the square root of the variance. Okay, the standard deviation is the square root of the variance. So in other words, the variance of x is the standard deviation of x squared. Okay, and we'll be dealing with variance a little later. The expected value of a random variable x plus or minus a c, a constant. A constant is just a number. A constant is just a number. Is that expected value plus a constant? Okay, and the variance of x plus or minus a constant, variance is standard deviation squared, so we're dealing with standard deviation, is simply the variance of x. Now, how does this have to do with what we just talked about? Adding or subtracting values does not affect measures of spread. That's what it just said right over here. Adding a constant changes the measures of position, but not spread. So it shows that in this formula right here. So, and we'll get to these a little bit later, but for now we're going to be using these formulas. These are on page 382 in your book. All right, so what we're going to do, we're going to take a look at multiplying every, we are going to answer this question right here. Find the mean and standard deviation for each cab company. So, company 1, the mean of Y for company 1 is very simple. That's the same as the expected value of Y for company 1. Basically, here's all we have to do. All we have to do is multiply the 250 times the expected value for company 1. So the mean of company 1, the expected value of company 1 of Y would be the mean of $2.50 times X. Isn't Y1 equal to 250 times X? Isn't that the formula we wrote up here? Okay. And multiplying does affect the measure of center. So all I would have to do is take 250 times what is X? What is the expected value of X? What's the mean of X? It's from above in your notes. It tells you right up, X is the length of a taxi ride. Look at your notes. What is mu of X? 5.2 miles. So all you're going to take is take 250 times 5.2 miles, and that gives you $13 is the expected cost. Now, I want you to think of this really simply. Okay, this is actually very easy. It just seems hard. Okay, if I expect on average to go 5.2 miles in a cab, which is what it says up here. If I expect to go an average of 5.2 miles in a cab, and the mean cost, the cost is figured by taking 250 times that, does it make sense that the average cost would be $2.50 times the 5.2 miles? Yeah, you're going to pay $2.50 a mile. Okay. So what is the standard deviation of company 1? So the standard deviation of Y for company 1 is the standard deviation of 2.50x, and is standard deviation affected by multiplying? Yes, standard deviation, everything is affected by multiplying, mean and standard deviation. So all I have to do is take $2.50 times the standard deviation of X. And what was the standard deviation of the length X, length of a taxi ride? It's 2.8. So the standard deviation would be $7. So the mean cost is $13. The standard deviation is $7 for company 1 of the cost. So now the mean for company 2 would be 5 plus 2 times the, 5 plus 2 times the mean for company 1, or 2, 5.2. So what's that? Measures of center are affected by both the multiplying and dividing, so 2 times 5.2 plus $5. $15.40. And the standard deviation for company 2 is not affected by adding 5, so it's just 2 times 2.8 miles, which is $5.60. So the key to this is you're just remembering that measures of center are affected by multiplication and addition. Measures of spread are only affected by multiplication. All right, so now we're just going to develop some things and work this question out on the next page. So, in addition to paying the fare, the passenger usually gives the driver a tip. Assume that the mean of the tip is $1.50 and the standard deviation of the tip is 70 cents. And that the tip does not depend on the fare, that is, tip and fare are independent. What are the mean and standard deviation of the new variable C, the cost of a trip including a tip? Now we're going to find this on the next page, but the cost of a trip, C, is equal to Y, the cost, plus the tip. Does that make sense? The cost we figured out up here. This was, or the y we figured out up here. The tip, we just now have information about the tip. Okay, so now we've got some notes down here at the bottom. The mean and variance of a combination of random variables. If x and y are random variables with means mu of x and mu of y and standard deviations sigma sub x and sigma sub y, then the mean of two random variables being added together is the expected value of the sum of two random variables is the sum of their expected values. And the expected value of the difference is the difference of their random variables. And that's actually, they give these rules in the book. It's the same thing using the expected value form. So these rules are the same as saying the expected value of x plus and minus y would be the expected value of x plus or minus the expected value of y. This is the same as these two rules. Now here's what you need to understand about this. The plus goes with the plus. The sign on top goes with the sign on top on this side. The sign on the bottom goes with the sign on the bottom. If you add random variables, you add their expected values. If you subtract random variables, you subtract their their expected values. Now, the mean formula works regardless of whether x and y are independent. Now with the standard deviations, okay, standard deviations. The standard deviations are different, and we actually don't talk about that. We talk about the variances. Okay, variance, and this is why we introduced variance. You don't need to interpret variance, you just need to be able to do order of operations with variance. So this is saying the standard deviation of the sum of two random variables is the sum of the standard deviation. So if you're combining two random variables and you want to find the standard deviation of the sum, you just add the standard deviations. Okay, and it's not really standard deviations though, because the standard deviation isn't squared, you add the variances. Okay, this is actually saying the same thing as the book has this rule and this rule. The variance of x plus or minus y is the variance of x always plus the variance of y. More variables means more variability. Standard deviation is the measure of how much something varies from the mean. Okay, so variability is a natural way, or variance is a natural way to describe it. So if you are adding or subtracting variances, you add the variances of the two functions. And we'll show how this works in formulas. So, and this you have to, on the top of the next page, just continuing the notes, the variance standard deviation formulas work only when x and y are independent. Always remember that variances add, it's variances. You don't add the standard deviations, you add the variance. The variance is the standard deviation squared. Even when we're subtracting random variables, we add their variances. More variables always means more variability. All four of these rules work for combining more than two random variables as well. So what we'd like to do now is we would like to use these rules to find the mean for the cost for company 1. So the mean cost and mean standard deviation for company 1. The mean standard deviation of the cost is the mean of y plus t, which is the mean of y plus the mean of t. And what's the mean of the cost of a trip for company 1? That was $13. And the mean of a tip is $1.50 to give us $14.50. The standard deviation, okay, we want to do the standard deviation, but I'm going to do the variance. The standard deviation of the cost squared is equal to the standard deviation, or the variance of y plus t. And basically it's the standard deviation squared of y plus the standard deviation squared of t. So that is going to be 7 squared plus 0.7 squared, which is 49.